For today's lesson, we will be discussing about reference angle. So we will be illustrating what is a reference angle, and also we will try to identify the reference angles. So let's start first with the definition of reference angle. A reference angle of an angle is the smallest positive acute angle formed between the terminal side and the x-axis. So we already discussed what the terminal side of an angle is. So reference angle, this is the angle formed between the terminal side of the given angle and also the x-axis. Regardless of where the angle ends, that is regardless of the location of the terminal side of the angle, so it can be located in any quadrant of the Cartesian plane or coordinate plane. The reference angle measures the closest distance of the terminal side to the x-axis. So we will just get the smallest acute angle that we can get or that can be formed using the terminal side of the angle and also the x-axis. Here are some illustrations of the reference angle. So before we proceed with this, just to recall, of course we have 4 quadrants in our Cartesian plane. So as you can see here, of course, this is the first quadrant, this is the second quadrant, the third quadrant, and the fourth quadrant. Now, the way of getting our reference angle depends on where is the terminal side or where is the location of our angle. So it depends now which quadrant will it fall. So first, let's say we have this angle right here, and let's say this green angle is 30 degrees. Now, since this one is the terminal side, let's say the initial side is here in our x-axis. This is the initial side of the angle, and then this green right here, this is the terminal side. Now, since this angle is 30 degrees and this one is the terminal side, take note that for the reference angle, we should get the smallest acute angle that the terminal side and the x-axis will form. So in this case, you have 2 angles. Actually, you can get this angle right here and also this angle. This is the terminal side, this is the x-axis. So you can also get this one and also this angle right here. But for reference angle, what we want is the smallest acute angle. Therefore, given that the angle is 30 degrees, our reference angle is also this one, which is also 30 degrees. Because that is the smallest angle that can be formed using the terminal side and also the x-axis. Another illustration, let's say we have this angle right here. This one now is our angle. Let's say it measures 120 degrees. So again, this is the initial side, and then this green right here is our terminal side. Now, we have to identify the angle that can be created using the terminal side and our x-axis. Now, the smallest angle that can be formed is this violet part right here. So again, this is the terminal side, this is the x-axis. So we can consider this one, and this is now the smallest angle that we can form using the terminal side of the angle 120 degrees and also the x-axis. So if this is 120 degrees, so what's left for us to get 180 degrees is 60 degrees. Therefore, the reference angle of 120 degrees is 60 degrees. And last illustration, let's say we have this angle right here. Again, this is the initial side, and then it rotates counterclockwise, and then the terminal side is now this segment here. Now, let's say the measure of this angle is 210 degrees. Okay, again, the measure of this angle is 210 degrees. So, take note, this is now the terminal side. Now, we have to identify an angle that can be formed using the x-axis and our terminal side. So, again, you have 2 choices. This angle right here or this bigger angle. But for reference angle, take note, what we need is the smallest acute angle that we can form using the terminal side and the x-axis. Therefore, we will be considering this angle right here. Now, since we know this straight line here, this is already 180 degrees. Now, to get this angle right here, just have to subtract 180 to 210. Therefore, the reference angle of 210 degrees is 30 degrees. There are formulas that we can also use so that it will be easier for us to identify the reference angles. So like what I've said a while ago, the location of the angle is really important because this will help us in determining the reference angle. So take note, if the angle is already in quadrant 1, then the reference angle of that is also the angle itself, because that is already the smallest angle that you can form using the terminal side and also the x-axis, because the other angle will become an obtuse angle, so which is not the one that we want. So take note, if the angle is in the quadrant 1, its reference angle is also itself. Now, if the location of the angle is in quadrant 2, like in our second example, so to get the reference angle, all we have to do is just to subtract the given theta to us, subtract it to 180 or to pi. So that will be 180 degrees minus theta or pi minus theta. So if we just go back to the example a while ago, as you can see, so this angle is now in the second quadrant, or the terminal side is on the second quadrant. So that means the smallest angle that can be formed is this angle right here. Now, to get this, all you have to do is to just subtract 120 or the given theta to us to 180, so that we can identify now this particular angle here. And if the angle is in the quadrant 3, so that means all we have to do is to get the theta and then subtract 180 to it, or theta minus pi. 180 and pi are just the same, so the other one is just in a radian form. So like what we did with the third example, 210 degrees is already on the third quadrant, and to get this angle right here, which is the smallest acute angle that we can get or that we can form using the terminal side and the x-axis, what we did is just to subtract 180 from the given theta to us. Okay, because this one is already 180, and then we just have to get the remaining. So that is how you will get the reference angle if the angle or the terminal side of the angle is on the third quadrant. And if the angle is located in the fourth quadrant, all you have to do is to subtract the given theta or angle to you to 360 or to 2 pi. So that will be 360 degrees minus theta or 2 pi minus theta. So again, these are the formulas that we can use in order for us to identify the reference angle of angles given their location in different quadrants. Now let's try to find the reference angle of the following. First, we have 85 degrees. In order for you to identify the reference angle, you should be familiar with the degrees in our Cartesian plane. So let me just quickly illustrate so that you can have an idea. So this is 0 degrees. And then this part right here, the positive y-axis, that is the 90 degrees, or that's the location of 90 degrees, or in radians, that is pi over 2. And then this part right here, this is the 180 degrees, or pi. And then the third one here is 270 degrees, or 3 pi over 2. This one also is the 360 degrees. So you should be familiar with the locations of the angle in the Cartesian plane so that you know where is the angle located. So if the angle is between 0 to 90, that's in the first quadrant. If it's between 90 to 180, second quadrant. 180 to 270, third quadrant. And 270 to 360, that's in the fourth quadrant. So now what we have is 85 degrees. Obviously this one is less than 90 degrees, so that means the location of this angle is in the first quadrant. Since the location of the angle is in the first quadrant. Therefore, its reference angle is the theta itself, or the angle itself. So, that means the reference angle of 85 degrees is also 85 degrees. Now, if we are to draw it in a Cartesian plane, so let's say this is the 85 degree angle. So this is now the terminal side, and of course the smallest acute angle that it can form using also the x-axis is this angle, because the other angle that can be formed is this one, which is obviously not an acute angle. So we don't have any choice, so therefore answer is 85 degrees. Next is we have 115 degrees. So you have to identify what is the location of 115 degrees. So it is less than 180 degrees but greater than 90 degrees. So therefore, it is located at quadrant 2. If the angle is located in quadrant 2, the formula that we can use is 180 minus the theta. So what we will do here now is to subtract 115 to our 180 degrees. So therefore, if we will do that, we will get 65 degrees as the answer. So therefore, 65 degrees is the reference angle of 115 degrees. Now, if we will illustrate this, so let's just say that this is the 115 degree angle. This one right here. Since this is the terminal side, and we need an angle that can be formed using the terminal side and the x-axis, so we can consider this angle right here because this one is the smallest. So 180 minus 150, so that will complete 180. So this now is 65 degrees. Another one is we have 220 degrees. So again, identify what's the location of the angle. So 222 degrees is in between 180 and 270. Therefore, it is located in the third quadrant. And if the angle is located in the third quadrant, then what we can do is to get the theta and then subtract 180 to it. So to solve for the reference angle, so 222 degrees minus 180 degrees, this will give us now 42 degrees. So 42 degrees now is the reference angle of 222 degrees. So let's illustrate it again. So let's say this is the 222 degrees. This one right here. And since this is the terminal side, the smallest angle that it can form together with the x-axis is this angle right here. Because the other one is already an obtuse angle. So this one is 42 degrees. Another example is we have negative 405 degrees. Now, if the angle is negative, we will be having a different solution for this. Because the formulas that we know, the one that I gave you a while ago or showed you a while ago, they will not work if the angle given to us is negative. So what we have to do first is to identify the coterminal angle of this negative angle that is a positive. So let's identify first where is negative 405 degrees if we will draw it in the Cartesian plane. So let's see. We have here this Cartesian plane. Since it's 405 degrees, negative 405 degrees, that means it is above 360 degrees. So what we will do is we will draw here. So from this will be our initial side, and since it's negative, so that means the movement of the terminal side will be clockwise. So it completes a whole rotation and somewhere here in the fourth quadrant. So this is our negative 405 degrees. What we will do is we have to identify a coterminal angle of negative 405 degrees that is a positive value or a positive angle. Because since we know here, this one is in fourth quadrant. So if the angle is in fourth quadrant, that means we're going to follow 360 minus the theta. And if we will be using the negative 405 degrees, so that will be 360 minus negative 405, or it will become 360 plus 405. So which will give us a different answer. So again, what we will do is we have to identify first the coterminal angle of negative 405 degrees that is positive. Now to recall, to identify the coterminal angle, we have the theta plus k times 360 degrees, where k refers to the number of rotations that we will consider. Now, since this angle right here already completes a one whole rotation and it already started its second rotation, so what we will do is, let's try to use k, which is equal to 2. So we have here negative 405 degrees plus, then we have 2 times 360 degrees, so that will give us negative 405 degrees plus 720 degrees, and then subtracting it, so we will get 315 degrees. So this is now the positive coterminal angle of negative 405 degrees. Okay, now we did not use 1 as the value of k, because if we use 1 as the value of k, the angle that we will get is still a negative value. So what we need is the positive coterminal angle of negative 405. Now if we will to draw this in our Cartesian plane, just for you to see, so it's 315 degrees, so that means it is in the fourth quadrant, so somewhere here. So this is our 315 degrees. Now, since it is coterminal with negative 405 degrees, so we will be using now 315 as the value of the theta for us to get the reference angle. So this will now be 360 degrees minus 315 degrees, which is equal to 45 degrees. So that will be now the reference angle of negative 405 degrees. Again, if the angle is negative, you have to identify first the positive coterminal angle of the given angle. Now that we already know the reference angles and also how to identify reference angles of different angles, we can use them to identify the different trigonometric functions, or we will use them to evaluate the trigonometric functions. Now, how are we going to evaluate trigonometric functions using the reference angle? First is, you have to find the reference angle for the given angle. So like what we did in the previous examples. Second, rewrite the original trigonometric function with the reference angle. Third, we have to affix the appropriate sign to the trigonometric function depending which quadrant the angle terminates in. So what we will do here is we have to identify or put the appropriate sign for the trigonometric points that we will get depending on the location of the angle. So if the angle is located in the first quadrant, so it's positive, positive. If it's in the second quadrant, positive, negative. Third quadrant, both negative. And fourth quadrant, positive and negative. So we will just change the sign depending on the location of our angle. And then fourth is, we evaluate now the trigonometric function. Now let's try to find the value of the 6 trigonometric functions of the following angles. First is we have 210 degrees. Now what we want to do here is to use or maximize the use of our reference angle in order for us to evaluate the function. So first is, let's identify the reference angle of 210 degrees. Since it is greater than 180 degrees but less than 270 degrees, that means it is located in the third quadrant. And if the angle is in the third quadrant, in order for us to identify the reference angle, that will be theta minus 180 degrees. So we will have here 210 degrees minus 180, which is 30 degrees. So 30 degrees now is the reference angle that we will use for 210 degrees. Now after that, we have to identify now the trigonometric point of 30 degrees. So using the unit circle, we can see that the trigonometric point of 30 degrees is square root of 3 over 2 and 1/2 for the y coordinate. But take note, 210 degrees is on the third quadrant. So that means we have to change the sign of these points right here. So this will be negative square root of 3 over 2 and negative 1/2. Again, we just change the sign of the coordinates because in the third quadrant, the signs of the x and y coordinates are both negative. Then after that, we can now solve for the 6 trigonometric functions. So for the sine of 210 degrees, so we will be using this point right here. So we know sine of theta is equal to y, so that is negative 1/2. Cosine of 210 degrees, cosine of theta is x, so that is negative square root of 3 over 2. For the tangent of 210 degrees, tangent is y over x. So negative 1/2 over negative square root of 3 over 2. So let's just solve this. Negative 1/2 times, then get the reciprocal, negative 2 over square root of 3. This will be cancelled. Negative times negative is positive. So 1 over square root of 3. And then we have to rationalize. So multiply both the numerator and denominator by square root of 3. So we have square root of 3 over 3 as our tangent. So these are the first 3 functions that we have. Now for the other 3, for the cosecant, secant, and cotangent, all we have to do is just get the reciprocal of these first 3 functions. So for the cosecant of 210 degrees, this is just the reciprocal of the sine. So since our sine is negative 1/2, therefore the cosecant is negative 2. For the secant of 210 degrees, this is just the reciprocal of cosine, which is the cosine is negative square root of 3 over 2. So therefore, it's negative 2 over square root of 3. And then we have to rationalize this. So multiply both sides by square root of 3. So multiply both the numerator and denominator by square root of 3. So we will get negative 2 square root of 3 all over 3. So this will be the secant of 210 degrees. And then for our cotangent of 210 degrees, we will just get the reciprocal of the tangent, which is, the tangent is square root of 3 over 3. Therefore, the reciprocal of that is 3 over square root of 3. And then rationalize. So we have 3 square root of 3 all over 3. So you can still cancel this. We will get square root of 3 as the answer. So we're now able to identify the 6 trigonometric functions of 210 degrees using the reference angle. Another example, let's have negative 780 degrees. Now we have to identify the reference angle of negative 780 degrees. But since this is negative, so we have to identify first the coterminal angle, a positive coterminal angle of this given angle. Now, since this is 780 degrees, that means it completes 2 full rotation, and that means it is greater than 720 degrees, which is 2 full rotations. So, if I are to just illustrate this angle, so it's negative 780. The movement will be clockwise. So, 1, 2. So, let's say somewhere here is our 780 degree angle. Now, to get the coterminal angle of this, so what we will do is, we'll follow the formula again, theta plus k times 360 degrees. But since it completes already 2 full rotations and started its third one, so what we will do, we will use 3 as the value of k. So we have here negative 780 degrees plus 3 times 360 degrees. So this one is negative 780 plus 1080. So this will give us 300. So this is now the coterminal angle of negative 780 degrees. So this is our 300-degree angle. So this is somewhere here. Okay, now that we already have the coterminal angle, we can now identify the reference angle. So since it's on the fourth quadrant, so it's 360 minus the angle, which is 300. Therefore, the reference angle of negative 780 degrees is 60 degrees. So we will be using now the trigonometric point of 60 degrees in order for us to identify the trigonometric functions of the given theta to us. So since this is 60, the trigonometric point should be 1/2 and square root of 3 over 2. But remember, negative 780 degrees is on the fourth quadrant. Therefore, we have to change the sign of the y-coordinate. So x is still positive. Y-coordinate is negative square root of 3 over 2. And then this is now the value that we will use. So for the sign of negative 780 degrees, this is just the y-coordinate. So this is negative square root of 3 over 2. For the cosine, so this is the x-coordinate. So we have 1/2. For the tangent of negative 780 degrees, so y over x, so negative square root of 3 over 2 over 1/2. Then simplify, negative square root of 3 over 2 times 2. This will be cancelled. We'll get negative square root of 3. And then for the rest, again, what we will do is just get the reciprocal of the first three. So for the cosecant of negative 780 degrees, this is just the reciprocal of our sine. Therefore, we have negative 2 over square root of 3. And then rationalize. So this will be negative 2 square root of 3 all over 3. That will be our cosecant. For the secant of negative 780, this is the reciprocal of the cosine. So therefore, we have 2 since the cosine is 1/2. So secant is 2. Then for the cotangent of negative 780 degrees, it's the reciprocal of the tangent. So our tangent is negative square root of 3. So its reciprocal is negative 1 over square root of 3. But we still have to rationalize this. So we have negative square root of 3 over 3 for the cotangent of the given angle. So again, these are now the 6 trigonometric functions of the given theta. And then for our last example, let's just have 5 pi over 4 radian. So we have to identify where is this angle located. So if you are to draw it in the Cartesian plane, you can find 5 pi over 4 in the third quadrant. So this angle right here, let's say this is 5 pi over 4. Now since this one is on the third quadrant, therefore we have to now solve for the reference angle using the formula theta minus pi. So the theta that we have is 5 pi over 4 and then minus pi. So this will just become 5 pi over 4 minus, and then this, we can write this as 4 pi over 4. So therefore, the reference angle will be pi over 4. Now from the unit circle, we can identify now the trigonometric point of pi over 4, which is square root of 2 over 2, square root of 2 over 2. But since the given angle 5 pi over 4 is in the third quadrant, that means we have to change the coordinates or the sign of the coordinates. So both of them will become negative. So negative square root of 2 over 2 and negative square root of 2 over 2 as well. And then let's now identify the functions. So sine of 5 pi over 4. So we have negative square root of 2 over 2. We're just getting the y-coordinate. For the cosine of 5 pi over 4, we'll just get the x-coordinate, so negative square root of 2 over 2. For the tangent of 5 pi over 4, you just have to divide x and y, or y and x. You just have to divide y and x. So we have negative square root of 2 over 2 all over negative square root of 2 over 2. And then this will become negative square root of 2 over 2 times negative 2 over square root of 2. So this will be cancelled. The other one will also be cancelled. Negative times negative is positive. Therefore, we just have 1 as our answer. And then for the other three functions, all we have to do is to get the reciprocal. So for the cosecant of 5 pi over 4, get the reciprocal of our sign, which is negative square root of 2 over 2. So therefore, the cosecant will be negative 2 over square root of 2. So you have to rationalize this. This will become negative 2 square root of 2 all over 2. You can still cancel this. Then we'll have negative. So negative square root of 2 for our cosecant. For the secant of 5 pi over 4, get the reciprocal. So the cosine is negative square root of 2 over 2. So its reciprocal is again negative 2 over square root of 2, which is just the same as with the first one. So we'll just apply the same process. So we have negative 2 square root of 2 all over 2 cancelled. Then we have negative 2 square root of 2 as the secant. For the cotangent, reciprocal of our tangent, so remember tangent is 1, so therefore its reciprocal is also 1. So that will be the cotangent of the given angle. So that's it for today. I hope you learned something about how to illustrate the reference angle, how to identify them, as well as how to use the reference angle in order to evaluate the different trigonometric functions of angles. And see you next time.